And the next thing is calculating uncertainty of tau, which is what we're going to be using. So you guys already took in the partial derivatives before below. You can use those to create your equation. And I need to define first the uncertainty of T, the uncertainty of temperature, which I'm calling U dot. Dot is use the period button. This is a text subscript, not an array subscript. And then I'm going to do the control equals, which means the definitions equals. I'm going to say it's half a degree. I need this value in order to calculate the overall uncertainty of tau. So I'm going to call my overall uncertainty of tau U dot, and then I'm going to go to my Greek toolbar, tau. I'm going to control equals, or the definition equals. And then I'm going to put a square root in. You guys can figure out how to do that. It's the backslash button is a shortcut for it, by the way. And then I'm going to open that file that I put online so that you guys can look at it and see how to do systematic uncertainty. And I'm going to type that equation in directly, and then I'm going to show you how to use it with an array. So now, opening that file that I posted online for you guys, in order to see the equation that I posted, we can now type in that equation, and then we can use the proper arrays and the proper definitions of time and temperature to calculate our uncertainty for each individual point. So now, just typing in this equation here that you see, I get minus t divided by ln of y of t, which is our big T from our equations we defined up here, because that's time. That's the temperature at any given time. So that's just our t here, minus our y infinity, which is 97 in this case, divided by y naught, which is 25 minus 97, square that, times it by t again, minus 97, and then multiply that by u of big T, or the uncertainty of our temperature, and then square all this. And then we're going to add the next set of terms, and so on and so forth. So now I'm going to add and look at this term and modify it. So it's y naught instead of y of t, so I'm going to put 25 here. And then our last term is the term that's got a lot in it. So I'm going to go ahead and scroll over to that term on here as well. And I'm going to go ahead and start typing it in. So then it's y of t, which is big T, minus 97. That divided by 25 minus 97 minus 1 divided by 25 minus 97 times by, again, 25 minus 97, which are my infinity and my initial temperatures. So then, now I have my equation in here, and as you can see here, it's not liking this specific part. And this is because when t is equal to 97, it's 0, and ln of 0 is undefined, and that's why we're getting all this uncertainty here. So what I'm going to do is I'm going to create an index I to graph this over, to find my uncertainties over. So I'm going to go through my matrix here, and I'm going to find which values that I want to take. So I'll take index 35, because if I plug in 25 here, this bottom is going to be okay. It'll just give you, it should give you a 1. So I can have all the indices all the way through here. That'll be fine. Actually, that won't work either, because if you have 25, ln of 1 is 0. So you don't want to pick the initial point. So I'm going to pick at index 35 here, and then I'm going to go to index 64, just because of the nature of this graph, the nature of the ln of t and this subtraction area. So the index array I'm going to create is I. It's defined as 35, 36, 2. I said I was going to go to 64. And this little button right here, those little dot dot dot, is from the colon button. When you hit no shift, just colon, and then it'll give you this dot dot dot, and then I'm going to go to 64. What I'm going to do now is I'm going to do T array I, and the array button is the bracket facing right, the square bracket, not the parentheses. And I got to do the same thing with temperature, with the time, and then all the t's that we have that are calling the y of t value we need to do this for. And same thing with the time, because the time needs to be the same at the same point that we're evaluating our temperature uncertainty at. Alright, so now I have those all inputted correctly. And I'm going to also put an array on my u, because I put an array on these values. I need to put an array on my variable so it knows where to place the values in the matrix of the resultant. So then now I type in u dot just tau from my Greek toolbar. You don't need to put the array index in it because it's already defined in it. And then equals, and then it's going to spit out the uncertainty. And then you can see it only took a second, and it showed all 64. But the reason why it's not showing the ones before is because all of those wouldn't be a good value. Now you can see here all the values you can get. And as you can see, the first few points maybe weren't good points to pick. You can see the uncertainties were very, very high. And then you can see the points near to the infinity values were very low uncertainties. Now you can see how each of these have an uncertainty. Now there's two ways to replicate this uncertainty and pronounce it or provide it as one value. Since there's multiple values for the same tau, this is only calculating for one tau. So what we can do is we can actually take the average, or we can take the maximum. So using the maximum method, it'll only take the highest value, the highest uncertainty, and then you'll use that as the uncertainty to couple with your tau. Or you can take the average uncertainty and couple that with your tau. The maximum would probably be better since it gives you the biggest uncertainty that you have, which is what you're going to want to use, but average is acceptable as well. Now if you take the average of this, it's not going to be a very good average because you can see all these zeros. It's going to pull it down. And then if you take the maximum, the same thing's going to happen. It's going to be 365. So the way to take the average in MathCad is very simple. It's just mean of the function u comma u dot tau equals, and it'll give you the mean. And then we can take the maximum by saying max of u dot tau equals, and it'll give you the maximum. And we know the maximum is 365. So this is taking the mean, but the mean is based on all of our zeros as well. So if you really wanted to, you could do array I, and then it'll take the, it should take the mean. Nope, it's not going to do it like that. So you can either take the mean or you can take the max. Now, when you do this by yourself, you're going to, of course, crop your data so that you don't have these big long indexes like I do. And also, this was made up data, so it's going to not give you the proper results, and that's why all these zeros are here. It wasn't completely taken from the temperature. So this gives you a little insight on how to use MathCad to do uncertainty analysis.